in order to get rid of a radical, we're going to square both sides. Yeah. Don't worry about it. Don't worry about it. We're going to square both sides. And when you square a square root, the square root operation goes away. And you're left with 2x minus 4 is equal to 36. Now you can simply just solve. You add the 4, and we get 2x is equal to 40. Divide by 2, and we get x is equal to 20. What could I do to check my answer? You can plug it back in. And watch what happens when I plug it back in. I get the square root of, what is 2 times 20? 40 minus 4. So I get the square root of 36. And we say the square root, we say when we take the square root of something, like a square root of a number like that, we just lift the positive, okay? So we have positive 6. So it looks like I got the correct answer, didn't I? Okay. What's different about number 2? So what that means is it's the cubed root. How do you think I get rid of a cubed root? In order to get rid of a square root, I squared both sides. So to get rid of a cubed root, I will cube both sides. However, before you cube it, you should first move the 3 over. So we want to isolate the cubed root. So I'm going to subtract 3 to get the cubed root of x minus 3 is equal to 2. So now I have just the cubed root on one side. So now I can go ahead and do what to both sides? Cube it. And when you cube a cube root, it goes away and leaves you with x minus 3 is equal to, and what is 2 cubed? It's not 6, it is 8. Add the 3 to both sides and x is equal to 11. If you plug that in, you would definitely get 5 as your answer. Good question. We take 11 and we do 11 minus 3 is 8. The cube root of 8 is 2, and 2 plus 3 is 5. So it worked out. Better? All right. Number 3, I'm back to a square root. What should I do first? I first divide by 3. Notice how it's 3 times out front. You want there to be just the square root or the cubed root. So I divide both sides by 3. And I get the square root of x minus 5 is equal to 4. Now that I have just the square root, I can square both sides. And I get x minus 5 is equal to 16. Add the 5, I get x is 21. Number 4 looks like kind of all these put together. I've got 3 steps I need to kind of take here right away. What do you think the first step is? First thing I should do. Subtract the 2. I get 4 times the cubed root of 2x minus 6 is equal to 28. Next step. Divide off the 4, and I get the cubed root of 2x minus 6 is equal to 7. Now what? Cube both sides. Two x minus 6 is equal to, and 7 cubed, does anybody remember off the top of their head? 243. I add 6 to both sides. 2x is equal to 249. And divide by 2, x is 249 over 2. What's different about number 5? Yeah, there's 2 square roots. I have a square root equal to a square root. So notice that you have a square root on both sides. There's nothing you can really move. So all we're going to do is we are just going to square both sides. And what happens when I square both sides? Square root goes away. I get x minus 5 is equal to 4x plus 3. I'll subtract the 4x over, and I get negative 3x minus 5 is equal to 3. I'm not sure. Then I add the 5 over. I get x is equal to negative 8/3. Now, I'm not going to do this to you on the test, but I do want you to know that if you were to plug in negative 8/3, okay, you would get negative 8/3 minus 5. What would you have underneath the square root sign? Would you have a positive number or a negative number? If you did negative 8/3 minus 5, would that be positive or negative? Negative, right? Let's suppose it was x equals negative 4, okay? What's negative 4 minus 5? Negative 9? You would get a negative number. Can you take the square root of a negative number? You can't. Sometimes when you square both sides, you come up with solutions that don't actually work. This technically is what we call an extraneous solution. I will not do that to you on the test. It does come up on the ACT. It does come up on the MCA. It's something you need to be prepared for. But technically, negative 8/3 is not a solution. Because when you plug it in, you get the square root of a negative. Doesn't actually work. Okay. All right. Let's try this one. I'm going to square both sides. And by the way, you don't know if it's an extraneous solution unless you check it every single time. Anytime you square both sides or something, you should check. And I get 2x plus 3 is equal to x squared. Uh-oh, now I don't just have x to the first power. Anybody know how we solve when it's x to the second power? We gather everything on one side. So I'm going to subtract the 2x over here. I'm going to subtract the 3 over here. I get 0 equals x squared minus 2x minus 3. We use our zero product property because what do we want to do to the x squared minus 2x minus 3? What should we do? Starts with F, rhymes with actor. We factor it to x and x minus 3 and plus 1. What are my solutions? 3 and negative 1. Now, let's check the solutions. Let's plug in 3. What is 2 times 3? Plus 3. And the square root of 9 is? So did that one work? Yep, it sure did. Okay, so 3 works. Let's plug in negative 1. 2 times negative 1 is negative 2, plus 3 is 1. And what's the square root of 1? 1. It's not negative 1, is it? So this one does not work. This, again, is an extraneous solution. It was an extra solution that does not work. 3 is the one that works. Two more. Square both sides. What do you get on the left-hand side? X plus 18. And on the right-hand side, it's x minus 2 times x minus 2, which is x squared minus 4x plus 4. So notice how this gets a little bit more complicated. We're going to push everything off to the right-hand side. So when I subtract my x over, I have a minus 5x. When I subtract my 18 over, I have a minus 14. Does that factor? What does it factor to? Minus 7 and plus 2. So my solutions are 7 and negative 2. I want you to talk with the people next to you and decide, do both of them work when you plug it back in? Does just one of them work when you plug it back in? Or do none of them work when you plug it back in? See if you can figure it out. Look at it for about 30 seconds. Does one of them work, none of them work, or both of them work? Try it. Try it. All right, we plug it in. 7 plus 18 is 25, so I have the square root of 25. And 7 minus 2 is 5. Is the square root of 25 equal to 5? Yep, so this one does work. Let's try the negative 2. Negative 2 plus 18 is 16, so I have the square root of 16. And then negative 2 minus 2 is negative 4. Is the square root of 16 negative 4? It's positive 4. So this one does not work. That one's extraneous. Get that, Morgan? That's a big smile on your face. Okay. All right. Well, thank you for trying. All right. Last one. This one looks complicated. It's really not that bad. Okay. And what we want to do in this situation is you see you have a square root and a square root, but you have the 4 out in front and you have the 3 out the front. So sometimes people want to, say, divide both sides by 4. And while that would get rid of this 4 right here, that 4 would be gone. Oh, that 4 would be gone. It's now over here. So there's no way of really getting rid of the 3 or 4 altogether. So we are going to try to just square both sides. And being we didn't get rid of the 4, we have to square the 4. So what do we get? 16 times, remember now the square root's gone, x plus 1. And then on the right side, 3 squared is 9 times x plus 2. So I have to distribute the 16 and the 9 all the way through. And I get 16x plus 16 is equal to 9x plus 18. I'm going to gather everything to one side. So I'll subtract my 9x over and get 7x plus 16 is equal to 18. And now I will subtract my 16 from both sides. And I get 7x is equal to 2. Divide by 7, and I get x is equal to 2/7. And sometimes your answers are hard to check, but this is a correct answer. And if you were to plug it in, the square root of that would end up being equal to the square root of that times 3. So we're good to go. There you go. There's an introduction into solving your radicals. You guys can open up your homework. I think we just have about 8 problems in your homework, and I'll make sure the answer key is posted. You should be good to go. We only have one more lesson after this, and that's tomorrow. Then we can start reviewing.